So the last lesson of our section is proving conjectures using deductive reasoning. So whenever we want to prove anything, it takes a lot more work to do than when we're not trying to prove something. So when we were trying to show that something was false, all we needed to do was find an example that made the statement false, and then the statement's automatically false. But when we're trying to prove it true, we need to try to prove it true for all cases. So what this means is that when you're trying to use deductive reasoning, you cannot use numbers to try to show a proof. You need to use variables. So way back when we did this earlier on, it was the what's my number riddle in an earlier lesson. We chose a number, so let's say 3. We doubled it, 6. We add 5, 11. So I can show the work here. Double it means add it to itself or multiply by 2. 6 plus 5 is equal to 11. Add my original number, which was 3, so 14. 14 add 7, 21. 21 divided by 3 is 7. And then 7 subtract my original number was 4. And I think our conjecture was that the number was always going to give us a 4. Let's just try it one more time to see if that was the case. So choose a number, 7, double it. 7 plus 7 is 14. Add 5. 14 plus 5 is 19. Add your original number. 19 plus 7 is 26. Add 7. 26 plus 7 is 33. 33 divided by 3 is 11. And subtract my original number. 11 minus 7 is 4. So my conjecture in this case would have been that the answer to this number riddle is always going to be a 4. Okay, so now in order to actually prove this, when we were doing the examples to look for the conjecture, we're actually choosing very specific numbers. So when we're doing a proof for what this is going to look like, we just need to choose a number. So I'm going to say let x be my number. If I want to double it, I can go x plus x, and those are like terms, like 1x plus another x means I have 2 x's. I'm going to add 5 to it, so I'm going to take my 2x and add 5. Add on my original number, so I'm going to take the previous step, 2x plus 5. Add on my original number, which was x. Now I'm going to open up the bracket, 2x plus 5 plus x, and I have like terms here, so 2x plus x, 2x's plus 1x is 3x plus 5. It says to add 7, so I'm going to take 3x plus 5, add on 7. So I'm going to open up the bracket. In this case, it doesn't really take me much to open up the bracket. I just have to open it up. 5 plus 7 are like terms. So 3x plus 12. Divide by 3. So I'm going to take my answer, divide each piece by 3. So 3x divided by 3, you're going to notice that the 3's are going to cancel out. If I take 12 and divide it by 3, I'm going to get a 4. And 3 divided by 3, I'm going to get a 1. So then my final simplified expression is x plus 4. And then it tells me to subtract my original number, x plus 4 minus x is going to be, I'm going to open up the bracket, x minus x are like terms. I have an x and I take it away and I get 4. So this shows me the proof that the result from this what's my number riddle will always be 4. So I'm just going to write that here. The result from the what's my number riddle is always 4. And this would be the proof right here. Now, this is probably the hardest section for Maths 20-2 students. So there are going to be other proofs that we do, and you just kind of have to hang in there. Some of them are challenging and some of them are a little less challenging, but this is kind of the top end of this section. Now what we're going to do is we're going to prove this number trick. So first, before I can prove it, I need to see what's actually going to happen. So let's look at some observations. Okay, so my observations, so let's choose a number, 5, multiply it by 4. 5 times 4 is equal to 20. Add 10 to it, 20 plus 10 is 30. Divide that number by 2. 30 divided by 2 is 15. Subtract 5. 15 take away 5 is 10. Divide that answer by 2. 10 divided by 2 is 5. And then add 3. 5 plus 3 is 8. So it looks like my answer may be an 8, but before I can actually make a conjecture, I probably need to try this again. Let's choose any other number, 3. Multiply it by 4. 3 times 4 is equal to 12. Add 10. 12 plus 10 is equal to 22. Divide by 2. 22 divided by 2 is equal to 11. Subtract 5. 11 subtract 5 is 6. Divide by 2. 6 divided by 2 is 3. And then add 3. 3 plus 3 is equal to 6. Now it looks like I probably made a mistake somewhere here because I don't know if this trick actually works. So 3, choose any number, multiply it by 4 is 12. Add 10, divide by 2, subtract 5, divide by 2, add 3. 5. 5 times 4 is 20. 20 plus 10 is 30. 30 divided by 2 is 15. 15 subtract 5 is 10. 10 divided by 2 is 5. 5 plus 3 is 8. So what you may notice here is that it may look like the answer is 3 more than the number you started with. This number was a 3, and then 3 more than it is 6. So let's try one more to see if this is the actual observation of potentially what's happening. Let's take a number. I'm going to choose 10. Multiply it by 4. 10 times 4 is equal to 40. Add 10. 40 plus 10 is equal to 50. Divide by 2. 50 divided by 2 is 25. Subtract 5. 25 take away 5 is 20. Divide by 2. 20 divided by 2 is 10. And then add 3. 10 plus 3 equals 13. So it does seem to hold true because my original number was 10. And if I add 3 to it, I get 13. So my conjecture here, let's just try to write a conjecture. The conjecture is the result of the number trick will be 3 more than my original number. Now again, this conjecture could be true or false. If I want to show that the conjecture is false, I just need to find an example that doesn't do this. But instead, I'm going to try to prove my conjecture because I think this is actually what's happening. So let's say step 1, I'm going to choose X. Step 2, and I'm going to label these with steps. 1, 2, 3, 4. Let's put a dot in there. 5, 6, 7. So choose a number. I chose X. Multiply that number by 4. So 4 times X is just 4X. Add 10 to this number. So 4X plus 10. Divide by 2. So remember, when we're dividing by 2, we divide each term by 2. So 4 divided by 2 is 2, and then there's still my x there. 10 divided by 2 is 5, but there's a positive, so positive 5. Step 5 would be to subtract 5, so 2x plus 5 was my number. Subtract 5, I get 2x. Step 6 is to divide by 2. I get my original number. And then step 7 is to add 3. So we can see that this step means my original number plus 3, which is what I was trying to prove. So we can use a little box here to say that the proof is done. And again, I didn't specify a starting number for here, so I know that I've done a proof. And this is going to be always true no matter what value my x is going to be. Now these ones get a little bit more challenging. It says to prove that the sum of two even integers is always even. So let's decode some of this. The word sum means I'm adding together. This is going to tell me what I'm adding together, two even integers. Now the part that's challenging is when you think of an even number, you need to think of numbers as 0, 2, 4, 6, 8, and so forth. So an even number is always a multiple of 2. So I'm going to call an even number to look like a 2x. This is what an even number will always look like. And x can be anything you want it to be. If there's a 2 times the number you have, it is going to be even. Okay, so I'm going to add two even integers. So I'm going to say let 2x be an even integer. And I'm going to let 2y, because we need any two integers, be the second even integer. Now what I want to show is that the result is always even. So what I need to show is that the result is 2 times anything here. Okay, so I need to take the sum of my two numbers, 2x plus 2y, and this is equal to 2, and now they both have a common 2 in it, so I'm going to factor it out, and I'm left with 2x divided by 2 is x, 2y divided by 2 is y, and you can see that this is in the format 2 times something, which means this result is even. And then we're done. We've shown that the result is always going to be even. Okay, the difference between consecutive perfect squares is always an odd number. Sometimes the hard part of these problems is just to decode the words. The difference means I'm going to subtract two numbers, usually the bigger minus the smaller. Consecutive numbers means one after the other. So for example, 6 and 7 would be consecutive, 7 and 8 would be consecutive, and so forth. Now they say here, what do they need to be consecutive? They need to be consecutive perfect squares. So let's just write a bunch of perfect squares down. 1, 4, 9, 16. If you're not sure how I'm getting those, we're doing 1 squared, 2 squared, 3 squared, 4 squared, and so forth. 5 squared is 25, and so forth. So I'm actually taking consecutive numbers, but not actually numbers like 6 and 7, 7 and 8. I'm taking consecutive perfect squares. So 1 and 4 would be a consecutive perfect square. 4 and 9 would be a consecutive perfect square. So they just need to be beside each other. And I want to take the difference between them. So let's take let x squared be, and let me slow this down a little bit. Let's let x be a number. That number squared would be a perfect square. is a perfect square. Okay, now I need to take a consecutive perfect square. So I need to let x plus 1 be a number. So this was like my number 1, and then I squared it. So let's write it like this. So I took the number 1, and then I squared it. The next consecutive number would be 2, and then I square it. So now what I need to do in this case is take my next number, which was x plus 1, and square it, is the next consecutive perfect square. So now that we understand the condition, we need to understand what we need to try to show as a result. So the result here needs to be that there's an odd number. Now in the previous example, we talked about an even number looking like a 2x. So an odd number would look like a 2x. That's even, and then if I add 1 to it, it would be odd. So here, we're looking for 2 times something, and then we want a plus 1 on the outside to make it odd. So this is what odd means in math terms. Okay, so now we have to take these 2 perfect squares and we have to actually subtract them. So now let's simplify this out. X plus 1 times x plus 1 minus x squared. Now I know in our class we talked about doing a box to help you organize your thinking with the squaring, but you don't have to. X plus 1, x plus 1, or you just do your distribution. Okay, x times x is x squared, x times 1 is x times 1 is x, 1 times 1 is 1. So this result is x squared plus x plus 1 minus x squared. Those terms cancel each other out because they're like terms. There's another set of like terms also, the plus x and the plus x. So I get 2x plus 1, and now you can see that this is exactly the format I need. 2 times something plus 1. So I know that this result is an odd number. So we're done. I took 2 consecutive numbers, or 2 consecutive perfect squares, and I subtract them, the difference between them, and the result looks like 2x plus 1, which will always be odd, because 2x is even. I add 1, it's going to be odd. Okay, so there will be an assignment posted next week for you guys to work through these ideas. Again, as always, if you have questions, feel free to email your teacher.